What is Java? Java is a high-level, general-purpose programming language. It was introduced in 1995 by a team at Sun Microsystem and later acquired by Oracle. Installing Java and setting up IntelliJ or Eclipse. You will learn how to install the Java Development Kit (JDK). Set up your environment using a professional-grade code editor like IntelliJ, IDEA, or Eclipse. Step 1. Installing the Java Development Kit (JDK). Go to official website of Oracle, and with Java downloads you can click in here, and under the Java downloads you can scroll down, and here are the options for different operating systems like Linux, macOS, or Windows. You can click on any of these that you are using, but for now we just go with Windows. And here are three different options, like we have compressed archive and .exe file as well, and MSI installer as well. So if you want to install a JDK on this PC that you are working on, then you can download the exe file as well and you can run it. Follow the installation steps like you would for any other software. After installation, open your command prompt if you're using Windows, or terminal if you're using Mac or Linux, and type. You can just go in here and write cmd. So here you can write Java --, and version, and press enter. If it shows the version number, you are good to go. This simple check is how programmers confirm that Java is properly installed. It's like checking if your car has fuel before starting the engine. Step 2. Choosing and setting up your IDE, IntelliJ or Eclipse. An IDE, Integrated Development Environment, is where you will write, run, and manage your Java programs. Option 1. IntelliJ IDEA, recommended for beginners. You can just go to the official websites of JetBrains and click in here to download the IntelliJ IDEA, and you can click in here and this interface will be opened, and you can just click on this download. You can accept the cookies and click on this download. Here you have three different operating systems options like Windows, Mac OS, or Linux. So if you are using any of these, you can click in here. If you're using Linux, if you're using Mac, then you can click in here and just download any of these versions. But if you're using Windows, then you can click in here and download the exe file to install the IntelliJ in your PC. Download the Community Edition, it's free. Install it and launch the application. Option 2. Eclipse, an industry classic. Visit the official website of Eclipse and click in here to download the Eclipse. And here are the options, and you can click in here to download. So you can just click in here to download. You can accept the cookies. Download, and there is a version that you are using. You can just click in here, then download will be started, and after downloading the exe file, run the installer and select a directory for your workspace. And after the installation, you can click in here and this interface will be open for Eclipse, and you can just go to this file, new, and Java project. Inside the project, create a new class file under the CRC, and you can just name the project as Java course for beginners, and you can just click on next and create a class in CRC. Here you can see it will be the default output folder as this one. As you have named the project, you can click on finish, and here you can see this. And to create a class, you can just click in here and click on new, click on the class, and you can just name it as main. Click finish. So you have this project name, Java course for beginners, and the class name is main.java. So here you can see, here is a public class name with main that you have created right now. Both IntelliJ and Eclipse are excellent tools. IntelliJ is a bit more modern and beginner friendly, while Eclipse gives you a look at what's often used in large companies. Step 3. Running your first program. In your new Java class, type this code as public class, and class name is main, and you can start with braces. And now public static void main, the class name, and now you just have to pass the arguments as string and with these signs and args. And now if you want to output something, you can write in here as system.out.println, and you just have to write the phrase or something that you want to print in double quotes. For example, hello Java with exclamation mark, but don't forget to add semicolon and close this as this one. And here you can see you have written the first code as public class main, as you have named this in here, and public static void is like the keyword that we use to call the class, and these are the variables. Here you can pass it, and now you want to print this out as hello Java. Now hit the run button, a green triangle icon in here. You can click in here and click on OK. Here you can see we have output as hello Java that we wanted to print in here, and you can just convert it into, for example, hello world, and click on this icon, press OK, and now the output has been changed into hello world that you really wanted to print in here. That's your first Java program. It may be short, but it's a huge step. You have gone from having nothing installed to successfully running your first bit of a code, your first Java program, hello world. Here you can see you can create a Java project from here. Create a Java project and name a project as Java for beginners, and you just have named the project as this one. Click on next and finish. So here you can see you have a project name as Java for beginners. You can right click on that, go to new and click on class. Here you can name it as main, class name main, and click on finish. So you have a class name as main. So you have created a class, and now type the following code. You can write in here as public static void. This is the main syntax that you will be using on daily basis if you will be working on Java, and you have to write in here as the class name main, parenthesis, now the string, and with these brackets and args, and you just have to start with braces. And if you want to print something, then you will have this syntax as system dot out dot print ln and brackets, and in double quotes you can write the word or phrase that you want to print, and for example you will have to write in here as hello world with exclamation mark, and don't forget to hit semicolon. So here you can see there is no error. If there was any error, for example if you skip this one, then this will highlight that there is an error on this line, and when you just hover over that, it says syntax error, insert semicolon to complete block statement, and when you just hit semicolon, then this cross will be gone. Let's break it down so it actually makes sense. Breaking down the code. Public class main. This line defines a class. Think of a class as a container for your code. Java requires all code to live inside a class. Public static void main, string, and args. For that, it means this is the starting point of any Java program. It's where your code begins to run. You don't need to fully understand it right now. Just know that the program looks for this method to start. System.out.println. This line does the actual work. It tells Java to print the text inside the quotation marks to the screen. It's okay if some of the words look confusing. You will understand them better with time. For now, just get comfortable with typing, running, and observing the output. Running the program. After you have typed the code, look for the green run button in your IDE, usually a triangle button. In Eclipse, we have in here. When you click on it, it asks that whether you want to run this, and click OK. After clicking it, you should see this one, hello world, appear in the output window. That's it. You just wrote your first program. It's not about the message. It's about what just happened. You wrote instructions, your computer understood them, and it responded. Variables, data types, and user input. What are variables? Think of variables like a storage box. It holds information that your program can use, change, or display later. In Java, you must tell the computer what kind of information the variable will hold before using it. Here's a simple example. When you write int age equals 20, this line tells Java to create a variable called age, store the number 20 in it, use the int data type, which means it's an integer, a whole number. Variables help you write programs that work with different values without rewriting the entire code. You can update them, compare them, and use them in calculations. Common data types in Java. Java offers different data types depending on the kind of information you are working with. Here are a few of the most commonly used. Int for whole numbers, for example 5, 100, minus 3. Double for decimals, for example 3.14, 99.9. Char for single character, for example A, Z. String for text, for example hello, Java is fun. Boolean for true or false values. Let's see them in action. For example, if you want to store a value of year, you can just write in here as int and year is equal to 2025 and semicolon. And if you want to store a value of price, then it must be in the points or decimals, then you can write in here as double and write here as price equals 19.99 and semicolon. Or if you want to store a value of grade, char and grade equals single quote A or any grade that it could be and semicolon. And if you want to store a value of name, then you can write in here as string name equals double quotes and Sarah, for example, and semicolon. And if you want to store the value of true or false, then you can write in here as boolean is student equals true, semicolon. So this is how you can store the values using these data types. Each of these variables store a different type of data, and Java keeps track of what's stored, so it knows how to process it. Getting input from the user. So far, your programs have printed information, but what if you want to let users interact with your code? That's where Scanner comes in. It's a tool Java provides to let your program read input from the keyboard. Here's how to use it. You can write in here as import java.util.scanner and semicolon. You have to call the class that you have created. For example, you have created main class, then you can write in here as public class main and braces. Now public static void main with string brackets and args and braces again. Now if you want to have input from the users, you can write scanner input equals new scanner and system dot in and semicolon. And if you want to print something, you will write in here as system dot out dot println brackets, and in double quotes you can write in here as enter your name and semicolon, and at the end there must be semicolon, as the name must be string, so you just have to call the string data type and name equals input dot next line and at the end semicolon. Now you just want to add hello with the name, so you just will have to write in here as system dot out dot println, and in here you just will have to write in here as hello in double quotes and comma. And if you want the name to be added in here, then you can just add plus for concatenation and name plus in double quotes exclamation mark, and now close the parenthesis and semicolon. So here you have just asked for the input as name, enter your name, and you just want to add hello with that specific name with exclamation mark as well. So when you just run this code from here and press OK, so here you can see in output window it asks us that enter your name. For example, you just write in here as Robert and press enter. So it prints hello Robert, the name the user has given us as an input. So if you want to run again, then you can write in here, and let's assume you just write your name as Alex and press enter. So it says hello Alex. Let's break it down. Import java.util.scanner. This one tells Java to bring in the scanner tool. Scanner input is equal to new scanner system.in. This one creates the input reader. Input.nextLine. This one reads a full line of text from the user. Scanner can also read numbers. For example, if you want to add something in this code, and in next line you can write in here as system dot out dot print ln, and you can ask for the age. You can ask the user to enter your age, and colon and semicolon. And now you just want the age to be int, then you can just write int age is equal to input dot next int parenthesis and semicolon. But at the end you just want to add something in here as well. You just want to add hello with the name, and you can just replace the word hello with nice to meet you. Yeah, if you want to add a phrase in here, an extra one of the age, then you can just write in here as you are, for example, it could be in the double quotes as well, and double quotes and plus as concatenation age, again plus, and in double quotes you can write years old dot. You are asking for the username and the age as well, and the Java will print this according to this syntax. So when you just run this code in here and press OK, it asks your name. For example, you just write in here as Sarah, press enter. Now it asks your age. Let's assume you are 23 and press enter. So it says nice to meet you Sarah, you are 23 years old. So it has just converted the string and int into one sentence. This is the first time your program actually talks to someone and reacts to what they say. It's the foundation of building real-world apps, performing calculations and showing output. Whether you are building a calculator, processing form inputs, or creating a game score system, you will need these tools to make your code do real work. Arithmetic operators in Java. Java provides basic arithmetic operators to perform calculations. These include plus for addition, minus for subtraction, steric for multiplication, slash for division, percentage for remainder, also known as the modulo operator. Here is a quick example. Let's say you just want to add and subtract two numbers simultaneously, and for that you will write in here as the basic syntax with that, and after that you can write int a is equal to 10 for example, and int b is equal to 5. Now you just want to perform the calculation. For that you will write in here as int sum is equal to a plus b, and int product is equal to a steric b. Now you just want to print the results. Now for that you will write in here as system dot out dot println. In double quotes you will write in here as sum is, and now the plus sign for concatenation, and now the sum variable that you used in here to add two numbers, and with the semicolon, and to output the result of product, you will write in here as system.out.println, and in double quotes you will write product and plus sign to concatenate and product variable that you used in here with the semicolon. When you run this code by clicking in here and press OK, now you have sum as 15 and the product as 50, as 10 plus 5 is 15 and the 10 multiplied by 5 is 50. Integer versus decimal division. One of the most common sources of confusion for beginner is division. Let's look at this. For example, you have int x is equal to 7 and integer y is equal to 2. Now you just want to print the result, and you will write in here as system dot out dot print ln, and you just want to print the result for now as x divided by y and with semicolon. When you run this code, you have the result 3. Here you can see, even though 7 divided by 2 is 3.5, the result is 3. Why? Because int variable can only store whole numbers. Java throws away the decimal part. To get a more accurate result, you can use double in the place of int in here as double, and to replace int with double here as well. So when you run this code, you have 3.5. This gives the correct decimal answer because double supports floating point numbers. Always choose the right data type, depending on whether your result needs to include decimals, combining input, variables, and calculations. Let's build a simple program that takes two numbers from the user and performs operation on them. So, if you want to take the input from the user, you will write in here as import java.util.scanner. Okay, now you just want to take the input, so you will write in here as scanner input equals new scanner system.in and with semicolon. Now you will ask the user to enter the number by just giving him a prompt as system.out.println, and you will ask the user to enter the first number as enter first number and with semicolon. And user can input a number with decimal point as well, so you will not use int in here, you will use double. Num1 is equal to input dot next double. Now you just want the user to enter the second number. For that you will write in here as system dot out dot print ln, and in double quotes enter second number with semicolon at the end, and the second number must be double as well. For that you will write double. Num2 is equal to input dot next double function. Now it's time to perform the calculations. For that you will write in here as double sum is equal to num1 plus num2, and for the subtraction you will write in here as double difference is equal to num1 minus num2, and for the product you will write in here as double product is equal to num1 multiplied by num2, and for division we will write in here as double quotient is equal to num1 divided by num2. Now you have performed the calculations as well. It's time to print the output. For that, you will write in here as system dot out dot println, and you will write in here as sum is equal to sum, and system dot out dot println and difference, and plus sign for concatenation, and you will call the variable that was in here with the semicolon, and system dot out dot println product, and plus sign, and you can write in here as product. And for quotient, you can write in here as system dot out dot print, and you can write in here as quotient with plus sign and quotient with semicolon at that. Now you have asked the user for the input of two numbers, and it will perform the calculations and it will print the result. So when you just run this code in here, it asks to enter the first number. Let's assume you will have 52, and for the second number you have 45. Now the sum is 97.0, difference is 7, product is 2340, and the quotient is 1.155 and 4, you can say. Let's assume you just want to have the other calculations. You can run it again and enter the number. Let's assume you have 8 as first number, and let's assume 4 as a second number. So you have sum as 12, difference as 4, product as 32, and quotient is 2. This program demonstrates everything we have learned so far: variable, user input, arithmetic operations, and formatted output. Modulus operator. The modulo operator returns the remainder from division. It's useful in many scenarios, like checking if a number is even or odd. Let's assume you just want to check the number if it is a even or odd. For that, you can write in here as int num, and you can just give it a specific number. Let's assume 7. And to check whether it's even or odd, you can write in here as system dot out dot println, and for that you can just write in number modulo operator and divide by 2, and you can just have semicolon at the end. And when you run this code, output is 1, means it's odd. If the result is 0, the number is even. If it's 1, the number is odd. Formatting output, optional enhancement. Java's system.out.println function works well, but for more control over formatting, you can use system.out.printf function. Let's assume you have a number in here as double result equals the value of pi. Let's assume 3.14159, and it's so on. And you just want to print it in a way that it has been rounded. For that, you can write in here as system.out.printf function instead of println, and you can write in here as rounded value. If you want any two numbers after the decimal point, you can write in here as this sign and 0.2f, and now after the comma you can write in here as result and the semicolon. Now this has, you can see, 5 numbers after the decimal, and we just want to round off to 2 numbers after the decimal point. You can write in here as, and you can just run this program, and rounded value is 3.14. But let's assume if you want only one value, you can write in here as .1 and run this program, and it will have only one number after the decimal point. This is helpful when displaying currency, percentages, or neatly formatted numbers. Today, you took a major step forward in making your programs functional and useful. You now know how to perform calculations using Java and how to share results with the user through output. These are the building blocks behind nearly every useful software, calculators, e-commerce price tools, fitness trackers, and much more. Writing conditions, if, else, and comparisons. You will also learn comparison operators like equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to evaluate expressions. You will be able to write programs that behave intelligently and dynamically, changing their actions based on logic and user input. Basic if statement. The if statement allows your program to do something only if a condition is true. For example, you just want to run a program and it has integer score is equal to 85. Okay, and you just want to check whether the student has passed or not. And to check whether the student has passed, then you can just write in here as if parenthesis, and now the condition score is greater than or equal to 80. Okay, and now you just write the brackets, and now you just want to print as system dot out dot print ln you passed and semicolon. So when you run this program, if the score is 80 or higher, the program will print you passed. Here you can see as the score was greater than 80 as it had 85. If not, it won't print anything. Let's assume you just write in here as 65 for example, and you just run this program and it will print nothing. That's the simplest form of decision making in Java. Adding else. But if we want to respond differently when the condition is false, that's where else comes in. So for example, you just want to add else, you write in here as 85, and you can write in here as if this happens then you passed. You can just add else in here as else you just want to print as system dot out dot print ln, and you just want to print as you failed, and at the end semicolon. So if this statement is true, let's assume the score is greater than 80, then this will be printed. Else, it means if the score is less than 80, then this will be printed. So let's assume we just run this program in here. So here you can see it prints you passed as the score was greater than 80, but let's assume we just print in here as 65, and you just run this program. So it prints you failed. Now the program always prints something, either you passed or you failed based on the condition. Using else if for multiple conditions. When there are more than two possibilities, use else if. For example, we have int as score is equal to, let's assume 95 for now, and you are using if conditions as if score is greater than 90. Okay, then what it should do, system dot out dot print ln, and just print here as excellent with semicolon at the end. But if this statement is not true, then you can write else if and parenthesis score is greater than or equal to 80. Then what it should do, it should print as system dot out dot print ln and give it a title as good job and then semicolon. But if this statement is not true as well, so what should you do? As else if and score is greater than or equal to 70, let's assume, and you just want to print in here as brackets and system dot out dot print ln, and you just want to print in here as you passed. And if this statement is not true as well, then the program should print else and else system dot out dot print ln, try again, or work hard, you can write anything, and at the end semicolon. So you have written 4 conditions with greater than 90, greater than or equal to 80, greater than or equal to 70, and if the student couldn't get these marks, then the student should try again. So when you just run this program and click in here, it prints excellent, as you have given a score as 95, which is greater than 90, so it prints excellent. But let's assume you just print it here as 75 and click run. It says you passed, as it is greater than 70 but less than 80. And now let's assume you just write in here as 55 and run this program. It says try again, as it is less than any of these values as 90, 80 and 70. So the program should not print any of these, but this one, as the value is less than these given conditions. The program checks each condition in order from top to bottom. As soon as one is true, it stops checking and runs that block. Only one of the blocks will run, even if more than one condition is technically true. So let's assume if we just want to click in here as 85 and you just run this program, it says good job. Although this 85 is greater than 70 as well, and it should have printed try again as well, but the first condition was true as this one, so it just prints good job. Comparison operators. To make these decisions, you use comparison operators. These help you evaluate whether something is true or false. This represents equal to, and this represents not equal to, and this represents less than, this represents greater than, this represents less than or equal to, and if you want to use greater than or equal to, then you can use this sign. For example, you have int age is equal to 18, and you just want to check using boolean by using this one, system dot out dot print ln, and you just write right here as age is equal to 18, and you just run this program. It prints true, and let's assume you just write in here as system dot out dot print ln, and age is not equal to 21, and you just run this program. It prints true again as well. And let's assume you just want to write a greater than sign, and for that you can write in here as system dot out dot print ln, and age is greater than 16, and you just run this program and it prints true again. But let's assume you just write in here as 15 and you just run this program. It prints this one for false as well, as it is not equal to 18, but it prints true for 21, as this is not equal to 21, and as it prints false for this one as well, as it is less than 16. These expressions return a boolean value, either true or false. Logical operators. Sometimes you want to check more than one condition at a time. Use logical operators. AND all conditions must be true, or at least one condition must be true. For example, we have int age is equal to 25. Okay, and you just want to check whether the person can drive or not. For that, you can use boolean has license and is equal to true. Now you just use if condition as if age is greater than 18 and has license, then what it should do, and it should print something as system dot out dot print ln you can drive with a semicolon at the end. So when you just run this program, it prints you can drive as the age is 25 and it has license as well and it is greater than 18 as well. So it just prints you can drive. Both conditions must be true for the message to print. But let's assume you just want to print in here as 16 and you just run the program, then it won't print anything as we have not used else conditions. But let's assume you just want to use else condition as else system dot out dot print ln you cannot drive and the semicolon, and you just want to run this program and click in here. So it prints you cannot drive as the both conditions are not true as the age is less than 18 although he has license. Building a simple conditional program. Let's write a short program that checks if a number is positive, negative or 0. For that you can just start with an input scanner as import java.util.scanner, and you have class name as main and with these arguments, and you can just write in here as scanner input is equal to new scanner and system dot in the semicolon at that. So this is used to get the user input, and you just want the user to enter a number as system dot out dot print ln enter a number at the semicolon. So here you are just asking a user to enter a number to check whether it's positive, negative or 0. After taking input, so you just want it should be an integer. For that you can just write in here as int number is equal to input dot next int and this function. So now check the condition. You just have to write if number is greater than 0, then it should print system dot out dot print ln the number is positive and with semicolon at that. But else if number is less than 0, then it should print system dot out dot print ln the number is negative and semicolon at the end. But if both of the conditions are false, like if the number is equal to 0, then you can use the else condition as else with this and system dot out dot print ln write the number as the number is 0, semicolon at the end. Now when you just run this program, it asks you to enter a number, and you just write in here as 50 and click enter. It says the number is positive, but if you want to run it again and write minus 65 and click enter, it says the number is negative. But if you want to run it again and enter a number as 0, you can write in here and click enter. It says the number is 0 as this condition is true. This is a great example of how your program can think and adopt based on input. Common mistakes to avoid: forgetting curly braces when writing multiple lines inside a condition, using single equal to sign instead of double equal to sign for comparisons, as single equal to sign assigns a value and double equal to signs checks for equality, writing conditions that are always true or false, for example if true or if 1 is equal to 2. Project: build a simple grade calculator. Project overview: we are going to write a grade calculator program. The program will ask the user to enter their percentage score and return a letter grade based on the following scale: 90 and above A, 80 to 89 B, 70 to 79 C, 60 to 69 D, below 60 F. Before jumping into code, let's think through what we need. Input: we need to collect percentage score from the user. Storage: the score should be stored in a variable. Logic: we need to compare the score with grading thresholds. Output: we'll display the letter grade with a message. Writing the program step by step. Let's walk through the program in chunks. Step 1. Set up scanner for input. For that, you can write in here as import java.util.scanner. Okay, and next we have public static void main, as we have class name as main, and after that string and args. Now we'll start the curly braces and scanner input is equal to new scanner and system dot in. Here we have started the program and created a scanner to take user input. Step 2. Ask for the percentage score. For that, you can write here as system dot out dot println and ask the user to enter your percentage score and with semicolon. As you know, the percentage can be in decimal as well. For that, you can use double instead of integer. So you will write double score is equal to input and next double function. We're using double to allow decimal input, for example 88.5. Step 3. Apply if-else logic for grading. For that, if you will just start writing as if score is greater than or equal to 90 and score is less than or equal to 100, then what it should do? It should print as system dot out dot println as you got an A. Excellent. And with semicolon at the end. Else if score is greater than or equal to 80 Then what it should do, it should print as system dot out dot print ln as you got a B. Good job. And with semicolon at the end. And after that, else if this condition is not true as well, then you can just give it as condition as score greater than or equal to 70. Then it should print as system dot out dot print ln, and it should print as you got a C, you passed. And with semicolon at the end. And if this condition is not true as well, then you can write another condition as else if score is greater than or equal to 60. Then it should print system dot out dot print ln you got a D. Try to improve. Okay, and if this condition is not true as well, then you can write here as else if score is greater than or equal to 0, then it should print as system dot out dot print ln you got F. Don't give up. And if the user gives an invalid input, then we should use else condition as else system dot out dot print ln as invalid input score must be 0 or higher, and semicolon at the end. Let's break this down. We start by checking the highest range A. Here you can see from 90 to 100 range. Then we work our way down to B, C, D, and finally F. We also check for invalid inputs like negative numbers. This structure ensures the first matching condition is used and no unnecessary checks are performed. Adding finishing touches. You can personalize this further by asking the user for their name or by adding feedback based on performance. For example, thanks for using the great calculator. This makes the program feel complete and user-friendly. So when you just run this program, and here you can see, it just asks the user for their percentage score. Let's assume user gives us percentage score as 65. When you enter this, it says you got a D, try to improve. When you run this again and enter a percentage as 98, when you enter this, it says you got an A, excellent, as this has been completing this condition. So this is how you can build a simple grade calculator by using Java. The while loop explained. What is a while loop? A while loop lets you repeat a block of code as long as condition is true. Here is the basic format. And now you will be writing the while loop condition as while I is less than or equal to 5 curly braces, and you just want to print system dot out dot print ln, and you just want to print I semicolon and I plus plus. It means that every time the number will be increased and it will be printed out. So when you just run this program in here, and here you can see it prints 1, 2, 3, 4 and 5. What's happening here? We start with I is equal to 1. Here you can start with any number that you want to start with. The loop checks is I is less than or equal to 5. from this condition? If yes, then print it. Then I++ increases I by 1. This function increases by 1. This repeats until it becomes 6 and then the loop stops. This kind of loop is great when you don't know exactly how many times something will happen, but want to continue until a certain condition is no longer true. Common use case. Keep asking until correct. Loops are especially useful when interacting with users. For example, asking for a password. For that, you can just start writing code in here as import java.util.scanner to get the input from the user. And after that, you will just start writing code as scanner input is equal to new scanner and system dot in. And you just want to have a password, so string type is string password is equal to double quotes and this one. Now you just want to use the while loop as while and exclamation mark to check whether it's equal or not, then password dot equals, and you will just write the password in here in double quotes as secret 123 and close the parenthesis. Now you just will write here as system dot out dot print ln, and you just want to print as ask the user as enter password with semicolon as end. Now password is equal to input dot next line and function with semicolon at the end. And after that, if it becomes true, then you just want to print as system dot out dot print ln access granted. This will not be printed unless or until this password is true. So when you just run this program, it asks the user to enter a password. For example, we just print something else like secret 000. When you enter, it asks again because it is not equal to this one. So you will just write secret 123, and when you just press enter, it says access granted. So as it is equal to this one, as we just gave it a password to this one. The loops keeps running until the correct password is entered. Notice this part means as long as the password is not equal to this one, that specific one that you have already entered, then keep asking. Avoiding infinite loops. One of the most common mistakes with while loops is forgetting to update the condition. This can cause your program to run forever. Example of an infinite loop. For example, you just write int I is equal to 1 and while I is less than or equal to 5, then print as system dot out dot print ln and print I. But you forget to add I++. Basically, these double slashes means this is a comment. This line of code will not be running as this is a comment. So I just wrote this for your information. What if we just forget to add this one? So when you just run this program, then it will be printing 1 again and again as we have not added I++. This loop will never stop because I is never increased. Always make sure your loop moves toward making the condition false. Using break to exit early. Optional concept. Sometimes you want to stop the loop in the middle. You can use break. For example, you just write int I is equal to 1 while and just write true with curly braces on and write a condition as if I is greater than 5, then break system dot out.println, and you just want to print I, so with semicolon at the end, and I plus plus. So when you just run this program, it prints the same, but this is using break. This is less common for beginners, but can be useful in more advanced logic. For loops and iteration. What is a for loop? A for loop is used to repeat a block of code a set number of times. The structure includes three main parts. And this structure say, and the syntax of for loop is for, and first of all it will be initialization, and with semicolon, and condition, then semicolon, and update, and after that code to repeat. So this is the syntax for loop. Let's look at a simple example that prints numbers from 1 to 5. So let's assume you just want to write for loop in here, and you will just start writing as for, and initialization as int I is equal to 1. So this is initialization, and now the condition is I is less than or equal to 5, semicolon, and now the update is I plus plus, and you just want to print here as system dot out dot println, and you just want to print I, semicolon. So when you just run this program, it prints numbers from 1 to 5. Here's what's happening. Initialization int I is equal to 1. This sets a starting point, and the condition is I is less than or equal to 5. The loop continues while this is true, and the update I plus plus, after each run I increases by 1. When I reaches 6, the condition is false and the loop stops. Why use a for loop? You should use a for loop when you know how many times the loop needs to run. You want all the loop logic in one place: start, stop, step. You're working with counters or series like 1 to 10, even numbers, etc. It's especially helpful in repeating messages, performing math operations, displaying patterns, looping through arrays, which we'll explore later. Looping in reverse. You can count backwards by changing the update step. For example, you just want to change this condition as int is equal to, as int I is equal to 5, and I is greater than or equal to 1, and I minus minus, and you just want to print I. When you just run this program, this prints 5 down to 1. Just remember to adjust the condition and step I minus minus instead of I plus plus. Skipping values and custom steps. You don't have to increase by 1. You can skip values or step by more. For example, you can start writing a for condition as for int I is equal to 2, semicolon, and I is less than or equal to 10, semicolon, and I plus equal to 2. And you just want to print I as well. When you just run this program, it will print the even numbers 2, 4, 6, 8, and 10, unless else we have condition as it should be less than or equal to 10. So, but let's assume you just want to increase the number to 20 and run this program, and it will print the even numbers to 20. And you can even print squares as well. For that, you can just write in here as I is equal to 1, and let's assume you just want to have squares until 5, and I plus plus. But you just want to print I multiply by I, as I square is I multiply by I. So when you just run this program, it prints 1, 4, 9, 16, and 25 as the square of the numbers, and 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. The loop is flexible. You control how it behaves using the parameters. Avoiding off by 1 errors. This is a common beginner mistake: starting or ending the loop one step too early or too late. Example of a logical error. Let's assume you just want to print I in here, but you just skip the equal to sign in here, and you just skip this equal to part and write the condition as I is less than 5. So when you just run this code, it prints numbers from 1 to 4 and not 5. Always double check your start, end and condition to match the result you expect. Nested for loops. Optional concept. A for loop can live inside another for loop. This is useful for printing patterns like grids or triangles. For example, you just want to print a triangle of asterisk. Then you can just write a code as for int I is equal to 1 semicolon, I is less than or equal to 3 semicolon, and I plus plus. But you just want to add another loop, a for loop. You just write for int j is equal to 1 semicolon, j is less than or equal to I semicolon, and j plus plus. And now you just want to print static. For that you can just write system dot out dot print ln, and you just write static in here with semicolon at the end, and another print function as system dot out dot print ln and function semicolon at the end. So when you just run this program in here, it prints a triangle of asterisks. Each row adds one more star than the previous one. Nested loops and pattern printing. What are nested loops? A nested loop is when you place one loop inside another. This is especially useful when you want to repeat something in 2 dimensions like rows and columns. Here's the basic structure. For example, you just want to use nested loop. For that you can write for and initialization as int I is equal to 1, for example, and I is less than or equal to rows semicolon and I plus plus. And to control columns you can write here as for int j is equal to 1 and j is less than or equal to columns is less than or equal to columns semicolon and j plus plus. And after that you just will have to write the code that runs for each column in the row. So this is the syntax or code to nest loops in Java. Think of the outer loop controlling the rows and the inner loop controlling the columns, as this will be controlling the rows and this will be controlling the columns. Example 1. Rectangle pattern. Let's print a 3 by 5 rectangle of stars. For that you can write here as for int I is equal to 1 semicolon and I is less than or equal to 3 semicolon I plus plus, as we will be having 3 rows, but for columns we'll be writing for int j is equal to 1 semicolon and j is less than or equal to 5, as we'll be having 5 columns, so and again j plus plus. Now you just want to print asterisk in the rectangular form. For that you'll be using system dot out dot print ln, and you just want to print static. For that you will write static and at the end semicolon. And to move to the next line you will write another print function as system dot out dot print ln and this function only. So basically this moves to the next line. So when you just run this program, it prints a rectangle of asterisk. Here the outer loop runs 3 times. Here you can see we have put I is less than or equal to 3. And the inner loop, this one, runs 5 times per row, columns. Example 2, right angled triangle. For that, you can just change the condition by having rows as 4 and columns should be as long as I. And when you just run this program, it will print a right angled triangle. Notice how the inner loop depends on the outer loop. Here you can see inner loop depending on the outer loop. Each row adds one more star than the last. Example 3, number triangle. For example, you just want to have a triangle using the numbers from 1 to 5. For that, you can just start by using I is equal to 1 and I is less than or equal to 5. For example, you just will have 5 rows. And next we have to print, you can just write in here as J as column number plus, and concatenation should be just this semicolon. And after concatenation, you can just choose the quotation marks. It means you just want to print the column numbers, okay, along with the numbers as from 1 to 5 specifically. So when you just run this program by clicking here, so here you can see it prints a triangle with numbers like 1 and 2, 3, 4 and 5. This version prints numbers instead of stars and shows how to control what gets printed in the loop. Example 4, inverted triangle. To invert the triangle, you will have to change this for condition, okay, and this will remain the same as we'll be working on the rows only. So for that, you can just start by 5, okay, and I is greater than or equal to 1 and I minus minus, because we just want to invert the triangle as the I will be decreasing. So when you just run this program, and it will be printing asterisk. So when you just run this program, it will print a triangle but in inverted form. But here you can see the single star is missing as we just wrote the condition as I is greater than 1. When you just add I is greater than or equal to and you just run this program, then it will print the triangle with 1 star as well. Here the outer loop starts from 5 and goes down, reducing the number of stars each time. Here you can see this condition will decrease the stars by 1 on each row. Common mistakes with nested loops. Forgetting to reset the inner loop. Java does this automatically, but logically, you should always ensure the inner loops has a fixed restart point. Incorrect loop bounds. Off by 1 errors happen easily when you mix up less than or equal to and less than. Skipping system.out.println function. Without this, all output prints on the same line. Unclear variable names. Always choose meaningful names, row, column, etc. in complex patterns. What are methods and why use them? Why use methods in programming? As your programs grow, you will notice patterns, the same code being used in different places, or blocks of logic that would be easier to manage if they were separated. That's exactly what methods are for. Methods help you organize your code into smaller, manageable parts. Instead of writing everything in main, you break your logic into named blocks you can call whenever needed. What is a method? A method is a group of statements that perform a specific task. You can call it when you need it, and you can reuse it as often as you like. Here's a basic method that prints a greeting. Okay, you can just start writing code as public static void and greet. That will be our method and with parameters. And you can just print something that you want to be printed, and in here you can write system dot out dot println, and you just want to greet a person as hello, welcome to the course. and with semicolon. So you have created a method, and for now it's time to call it. You can write in here as greet obj object and is equal to new greet with function and then semicolon. And you can just call the method as obj dot greet with function and semicolon. So when you just run this program by clicking in here, okay, and it will print hello, welcome to the course, as you have printed in here. In method, public means this controls access. We'll keep it simple for now. And static, this lets you call the method without creating an object, prefer for now. And void, this means the method does not return anything. And greet, the name of the method. The parentheses are where you would include parameters if needed. And the code inside curly brackets is what runs when the method is called. Calling a method. Once a method is defined, you can call it from main function or from another method. For example, you just write code in here as public class main, as we have class name as main, and you will just start writing as public static void and main with a string and args, and we'll just write another code as greet method. Now we'll just call it as public static void and greet, and we just want to print system dot out dot print ln, and you just want to print hello student and semicolon at the end. So when you run this program by clicking here, press OK, and it will print hello student, as this is what we wanted to print. This code runs greet method when the program starts. Why methods matter? Let's say you want to display a welcome message at 5 different points in your program. Without a method, you would copy paste the same line 5 times. If the message ever changes, you would have to update all 5 places. With a method, you just update the code once, and every time you call it, the new version runs. Methods makes your code shorter, cleaner, and easier to update. Real example, calculator operations. For example, you just want to add and subtract. Okay, and you'll be using that in this one. When you would just want to add, you will write add in here and change the code to as int a is equal to 5 and b is equal to 3. All right, and you just want to print system dot out dot print ln, and you just want to print that sum and plus concatenation, it should be a plus b and with semicolon. And when you just want to call a subtract method, and you just will have to write public static void and subtract. Okay, and you will just write here, and you will just write int a is equal to 5 and b is equal to 3, and you just want to print system dot out dot print ln and the difference and plus for concatenation, and write a minus b and semicolon at the end. So when you just run this code, it says sum is 8 and difference is 2. Here you can see we have 2 different methods as add and subtract. So when you just click add, it shows that this part of code will be running add method and this one will be running the subtract method. The logic stays clean and each part does one job: creating and calling your own methods. Quick recap. What is a method? A method is a named block of code that performs a task. In the last lecture, we created simple methods with no input and no return value. Today, we'll make them more useful by giving them input using parameters. Creating a method with parameters. Let's write a method that adds two numbers and prints the result. For that, you can write in here as public static void, and we just name the method as add. And you can just pass the parameters as int a and int b. And next we have to add them. Int sum is equal to a plus b. And you just want to print the result as well. For that, you can write system dot out dot println and write sum with concatenation as sum. Okay, now in the main section you will have to call the method. Calling the method. To use this method, call it from main and pass values. For that, you can write in here as add 5 and 9, let's assume, and with semicolon. When you run this program by clicking in here, press OK, and it prints sum is equal to 14, as 9 plus 5 is 14. Each time you call add method, it uses the values you send in here. For example, let's assume you just use 3 and 7 for example, and run this program, and it prints the result as 10, as 3 plus 7 is 10. This is powerful. One method written once can be used with different data over and over again. For example, you just want to add 2 times and call the method as add and write 9 and 80 for example, and press enter and run this code, and it will print the result as 89 as well, as 9 plus 80 is 89. So each time you give it values and it will print it again. Why use parameters? Let's say you have a method that greets a user. For that, you can just write in here as, for example, you just change this program by using this one, and for example you just do this one, and you just change the name of this method as greet for example, and pass the parameter as string value, string name. Okay, and you just want to print as system dot out dot println, and you just want to greet the user as hello, and with plus sign that is used for concatenation, and name, and plus with exclamation mark with semicolon at the end. So you just have to call the method in the main by greet. For example, you just want to greet Sarah, so you will write in here as Sarah, and Alex as well, for example, greet and Alex with semicolon at the end. So when you just run this program by clicking here and OK, and it prints hello Sarah and hello Alex as well. Instead of writing separate methods for each name, you use one method and change the input. That's efficient, readable, and flexible. For example, if you want to add another method in here, as which says public static void, and let's assume it's just display scare, or you can just write scare display, and with parameters as int number. Okay, and now you just want to print it as system dot out dot println, and you just want to print it as scare of the number is, and plus sign as concatenation, and you just want to multiply with that specific number as number multiply by number. So, and semicolon at the end. But you just have to write in here as scare display, and you just have to give the number. For example, you write 5 in here and semicolon at the end. And when you just run this program by clicking here, okay, and it says scare of the number is 25, as 5 scare is 25, and hello Sarah as well. It calls the greet method as well and the scare display method as well. So you can call two different methods types as well. Each method does one specific job, which makes your code clean and easy to manage. What happens if you don't call a method? Nothing. The method exists, but Java won't run it unless it's called. Always make sure you call your custom methods at the right time from main function or from another method. Tips for writing good methods. Choose a clear name that describes what the method does. Keep it focused. One method should do one thing. Use parameters if your method needs input. Test each method individually to make sure it works. Passing information, parameters and return values. Quick review, why methods? For example, you just write a method in here as public static void and you just name it as greet user, and you just pass the parameters as string name, and you just write in here as system dot out dot println. You just want the phrase to be printed, then write hello and plus for concatenation and name with semicolon at the end. This method takes input but doesn't return anything. It simply prints a message. That's useful, but what if we want a method to give us something back, like a result we can use later? Part 1. Parameters. Sending information into methods. Let's say we want to write a method that multiplies two numbers. Here is how we define it with parameters. You can write here as public static void and for example multiply is the method name, and you just pass the parameters as int a and int b, and you just want to multiply them, so you will write int multiply or result is equal to a multiplied by b, and now you just want to print the result, so you will write system dot out dot println, and you just want to be printed as product equal to, you can write and concatenation plus sign and result, as we have used this in here, and semicolon at the end. Now from the main method we call it like this. In the main method we call it like this as multiply this method name and give the value as 4 and 5 with semicolon at the end. This sends the values 4 and 5 to the method, which stores them in a and b, multiplies them and prints the result. So when you run this program by clicking here, okay, and it prints product is equal to 20. Parameters let you reuse the same method for different data, saving time and improving clarity. Part 2. Return values. Getting results from methods. So far, our methods have printed output directly. But what if we want to store the result and use it later? Here's how we can return a value. For that, you can just write a method as public static, but now we'll be using int instead of void, so we'll be using int, and add will be the method name and int a and int b, and you can write in here as return a plus b. Notice that we changed the return type from void to int, here you can see, and we use return to send our result back like in here. Now we can store the result when we call it. For that you can write in here as in the main function you will write int sum is equal to add, and you will just give the values as, for example, 7 and 3, and you can print that as well. Like you can print as system dot out dot print ln, and you just want to print as sum is, and concatenation plus, and you will write sum as a function name and with semicolon at the end. So when you just run this program, it displays the result as sum is 10, as 7 plus 3 is 10. This gives you more flexibility. You can use sum in more calculations or checks later in your program. Part 3. Comparing void versus return methods. Let's look at the difference. First of all, the return method that we have used already in here, it gives you control. You decide what to do with the result. Print it, store it, use it in another method, etc. But if we use void instead of the return method, you will have to write void in here, and you will have to print by using this system dot out dot print ln, and you will write in here as a plus b with semicolon at the end. But if we have to use void method instead of return, so we'll have to change the int with void, and we'll have to remove this section as we don't need this, and we'll have to write a simple print method as system dot out dot print ln, and you just want to print as a plus b. But you will have to call the method as add and give two numbers as 3 and 6, for example, and semicolon at the end. And when you just run this program by clicking OK, it prints 9, or you can just give it as sum is, and plus and get continuation, and you just run this program and it says sum is 36. And when you just run this program in here by clicking OK, and it says sum is 9. The void method prints the result directly, here you can see, and it does not store anything. Part 4. Returning strings or other data types. Methods can return more than just numbers. For example, we have a method as public static, and we'll be using string instead of int or void as string, and you just name it as greet, and you just pass the parameter as string and name. And next we have to write, if we want to return the values, so we'll be using return, and you just want to return as welcome, and this one concatenation and name plus exclamation mark. For that we'll just write in here and semicolon. In main function we'll write, for example, string message is equal to greet and Alex, for example, and with semicolon, and you just want to print the message as system dot out dot print ln and message with semicolon at the end, with it should be in the double quotes. So the error has been removed. When you just run this code in here and click OK, it says welcome Alex, as welcome as this one and Alex this one. This keeps your method clean and reusable while giving you full control over how and when to display results. Part 5. Real example. Calculator with return values. Let's write a full example using return values. For example, you just write a method in here as public static, and we'll be using int as we want to subtract, so we'll be using subtract with parameters as int a and int b, and you just want to store the values, so we'll be using return return a minus b. And now if you want to do this subtraction and print the results, so you can use in here as public, as we are using in the main section, we'll be using int result is equal to subtract a subtract, and now we'll be giving the values as, for example, 10 and 3 semicolon at the end. And now you just want to print the results as system dot out dot println, and you will write the result as result and concatenation with result and semicolon at the end. Run this program by clicking here, okay, and it says result is 7, as 10 minus 3 is 7. You can also use this result in other calculations. For example, you can add int doubled is equal to result multiplied by 2, and print that system dot out dot println, and print doubled as, and plus sign for concatenation, and doubled with semicolon at the end. So when you just run this code, okay, and it says 7 is the result and 14 is doubled. For example, we just change the numbers as 15 and want to be subtract with 5, and run this code. It says result is 10 and double is 20, as it multiplied by 2 in here. This is how real programs work. They pass data around, return values from one method, and feed them into the next. Building a mini Java project. Number guessing game. Overview of the project. The game will generate a random number between 1 and 100. Ask the user to guess the number. Tell the user whether their guess is too high, too low, or correct. Keep asking until they guess correctly. Count and display the number of attempts. This project is simple, but includes many core programming ideas you will use in larger applications. Step 1. Import the scanner and random classes. To accept input and generate a random number, we will need two tools, as import java.util.scanner, and the second one will be import java.util.random. Step 2. Structure the program. Let's break our game into parts using methods. For example, you will be using public class, as we're using main, so we're using main. Now public static void and main with string and args. We'll be using two methods as greetUser and playgame. Now to define this method, we'll be using public static void and greetUser, and we want to greet the user by printing as system.out.println, and we just want to print as welcome to the number guessing game, and you just want to print it again as system.out.println, as I'm thinking of a number between number between 1 and 100. So these two lines will be displayed before starting a game. And after that, we have started with a greeting method and separated logic for the game. Step 3. Generating the random number. Inside play game method, we'll generate the number and set up user input. For that, we will be using public static void and the play game that we have used in here. So we'll be using play game. We have to generate a random number. For that, we'll be using random. Rand is equal to new random. And now you just have to get the input from the user, as the user has to guess a number between 1 to 100. So we'll just get the input from user as scanner input is equal to new scanner and system.in. And now you will have to generate a number between 1 to 100. For that, you can write in here as int number to guess is equal to rand dot next int into 100 plus 1. Random number between 1 and 100. And we'll have to write int guess and int attempt as well is equal to 0. From start it will be 0. Step 4, loop until correct guess. For that, you will write do and system dot out dot print ln, and you just want to print as enter your guess, as the user will guess a number or by entering an integer, and after that you will write guess is equal to input dot next int, and this will be the function, and attempt plus plus, as one attempt will be counted. Now we'll be using if condition, as if guess is less than number to guess, then what it should do, it should print as system dot out dot print ln too low, try again, too low, try again. Else if guess is greater than number to guess, then it should print as system dot out dot print ln, then it should say too high, try again, with semicolon at the end. And if the user guessed the number correctly, then it should say as else system dot out dot print ln, and it should print as correct. You guessed the number in and plus attempt and plus concatenation and attempts. Then it will let the user know that in how many attempts he or she has guessed it correctly. While guess is not equal to number to guess, it will have unlimited attempts unless or until the user guess the number. So when you just run this program by clicking in here, press OK, it just creates a user by this message, welcome to the number guessing game, and I'm thinking of a number between 1 to 100. So when the user gives it a guess as 56 for example, press enter, it says too high, try again. Let's assume we'll be using 25, it says too high again, and let's assume we'll be using 20, too low. It means that the range will be between 20 and 25, so we'll be using 22, too low. It means we have to go a little further. 23, correct, you guessed the number in 5 attempts. When you just run it again, for example, and press OK. So you will have to guess it again. For example, we'll be using 65 too high, 45 too low. It means that range will be between 45 and 65. So we'll be using 55, it is still low. We'll be using 58, too low. 60, correct. You guessed the number in 5 attempts. This is how you can build number guessing game in Java. Where to go from here? Next steps in Java. Now it's time to learn what lies ahead. We'll walk through the major areas that will take your skills from beginner to intermediate and eventually advanced. Whether you are interested in building apps, games, or web tools, there is a clear path forward. Mastering object-oriented programming. OOP. Most modern Java development is built on OOP. This means thinking in terms of objects like students, books, or orders and writing code that models how they behave. Key concepts you will learn include classes and objects, designing custom data types, encapsulation, keeping code organized and protected, inheritance, reusing code by creating relationships between classes, polymorphism, making your methods flexible and dynamic. Once you understand OOP, you will be able to build structured, scalable applications that are easier to manage and grow. Arrays and array lists. So far, we have worked with single variables, but in real-world projects, you will often need to store and work with multiple values like list of users, test scores, or inventory items. You will want to learn about arrays, fixed size list of values, array lists, flexible resizable lists, loop plus arrays, processing data in bulk. For example, you can write a program in here as int, and this sign is used for an array, and after that you will write a variable name as scores is equal to, and arrays items are written in curly braces. So you will write values as 45, let's assume 65, 75, and 85, for example, and semicolon at the end. And you just want to print these values, and now you'll be using for loop as for int score and scores. And now you just want to print the score as system dot out dot println, and you just want to print score and semicolon at the end. So when you just run this program by clicking here, okay, and it will just print the values that are written in here and in the sequence. Working with arrays will help you solve more complex problems efficiently. File handling and saving data. Soon, you will want your programs to store data permanently, like saving a user's login, recording a score, or logging activity. Java makes this possible with simple file handling tools. Reading from files to pull in saved data. Writing to files to store new results or logs. These features are essential in almost every type of software project. Java GUI development, JavaFX or Swing. Tired of working in the console? Ready to make programs with buttons, windows, and graphics? JavaFX allows you to build desktop applications with visual elements. You can create calculators with buttons, note-taking apps, simple drawing programs. This adds a professional, user-friendly layer to your Java knowledge. Practice real-world projects. Once you are confident with the above topics, you can challenge yourself with the real projects. A personal budgeting tool, a to-do list app with file saving, a quiz game with a GUI, a student management system using objects and lists. Building small but complete projects is the best way to learn. Each one teaches new patterns and builds your portfolio. Get comfortable with debugging and testing. Up to now, you may have fixed problems by trial and error. As you grow, you will want to learn how to trace errors using the debugger, how to test your methods and code pieces before using them, how to write cleaner, more reliable programs. This turns your programming from just working to working well. What if you want more? If you want to go beyond desktop apps, web development with Java. Learn about frameworks like Spring Boot for building back-end services and web APIs. Mobile app development. Java is still a popular choice for Android app development. Databases. Learn how to connect your programs to databases like MySQL using JDBC. How to continue learning. You can move forward by taking an intermediate Java course focused on OOP, GUI, or file handling. Reading Java books for beginners, for example, Head First Java. Practicing on platforms like HackerRank, LeetCode, or Code Wars. Building and sharing your projects on GitHub. The secret? Keep building, keep reading, keep asking questions. You don't have to know everything, you just have to keep learning.